In this lesson, we're going to learn the upper and the lower bounds of a measurement or a number. To start with, why do we have to get the upper and the lower bound of a number? Sometimes we may want to decide or determine the range of a given measurement. That is where we need the upper and the lower bounds of a given number. So an upper bound of a number is a number that is greater than or equal to the given number, while the lower bound is a number that is less than or equal to that given number. In other words, the upper bound is the maximum value it could have been before it was rounded up, while the lower bound is the exact opposite. That is, the minimum value it could have been before it was rounded. So if I have a number, for example, the dimension of a rectangle, which is given as the length is 5.4 centimeter to 1 decimal place, and then the width is 3.3 centimeter to 1 decimal place. This number 5.4 centimeter was a certain number before it was rounded to this 5.4, and this 3.3 was a certain number before it was rounded to 3.3. So that number that it was before it was rounded, the least of it is what we call the lower bound, while the highest of it is what we call the upper bound. Now the keynote here is the measurement is to 1 decimal place. That is, this has been rounded to 1 decimal place, and this too has been rounded to 1 decimal place. What was the figure before it was rounded to this very number? That is the number that would mean that are known as upper and the lower bound of the measurement. So the upper and the lower bound of the length can be seen as follows. Since they say the smallest number that we round up to give 5.4 is 5.35. Look at this, 5.35. When you round 5 to 1, you add it here, it becomes 5.4. So 5.4, the lower bound of 5.4 is the lower bound, and I'm writing upper. The lower bound of 5.4 is 5.35. Again, on the other hand, the biggest number that we round down to 5.4 is 5.44999999 indefinitely, which is approximately 5.45. So this is the highest number that you can round down to 5.4. Anything bigger than this, we round up to 5.5. But our number is 5.4. The biggest number, the highest number that can round down to 5.4 is 5.45. So this 5.45 is called the upper bound of this number 5.4. And if I have to represent that using inequality, recall we said that the lower bound is 5.35, while the upper bound is 5.45. So this is the number. If I have to represent that using inequality, we write as 5.35 is less than or equal to the length of the rectangle, or x or whatever. In this case, let me use length. And if this is less than 5.45. Take note of my use of symbol. The first symbol here is less than or equal to, meaning this number can actually round to 5.4. Whereas here I have only less than, because this number cannot round to 5.4. If I round this, it's going to give me 5.5. That is why it is called the upper bound. This is the upper bound. So if we are representing that in inequality. This can round to 5.4, but this does not round to 5.4. So 5.35 is less than or equal to the length, and the length is less than 5.45. So this is lower bound, this is upper bound. Now my approach, or the easiest way to me to get the lower and the upper bound of a number, is to use a number line. And I have outlined my steps here. The first step, first of all, identify the place value of the degree of accuracy. This is supposed to be or the degree of accuracy stated. Like the first example we did so far, they said to 1 decimal place. That is the degree of accuracy. Look at this other one here. Okay, still the same thing. This is to 1 decimal place. So then the second step, I will then represent the given number on the number line based on the degree of accuracy stated. So in that case, if I am to represent that on the number line, remember the measurement is 5.4. Next to 5.4, they say to 1 decimal place, what is the next digit to 5.4? It should be 5.5. The next digit to it is 5.6, and so it goes like that. Now, if you are coming down, before we get to 5.4, we had what? 5.3. Before 5.3, we have 5.2, and so on and so forth. So this is the digit in question. I want to get the upper and the lower bound of this digit. In between 5.4 and 5.5, there is a number. How do we get that number? The easiest way to get it is to get the average of 5.4 and 5.5. Look at this, 5.4 plus 5.5, then divided by 2. By the time we add that number and divide by 2, then use the calculator. 5.4 plus, if you have your calculator with you, you can do the same thing. 5.5. When we add it together, it gives us 10.9, then divided by 2. That gives us 5.45, which is the upper bound, which agrees with what we said earlier. Look at this. Then to get the lower bound, we add the number again to the next number to it, which is 5.3. So the lower bound is the number in between 5.3 and 5.4 itself. So take the average of 5.3 and 5.4. Let's do that again. 5.3 plus 5.4 and divided by 2. Using a calculator to add that to make it easier. 5.3 plus 5.4 and divided by 2. 5.35. 5.35. So this is the easiest way to get the upper and the lower bound of a number. Locate the number on the number line. Then, depending on the place value or the degree of accuracy given to you, you can see here I write this in capital letter. You need to take note of the degree of accuracy given to you. Here we are talking about 1 decimal place. That is why I have 5.4. The next number to it is 5.5. The next number to it is 5.6, and so it goes like that. So you need to take note of that. So that is that. So let's use that to do some example. The first example here says a number was given as 35.6 to 3 significant figures. Find the upper and the lower bounds of the number. So my approach, I will represent this number 35.6 on the number line. Let me draw my number line. I have 35.6. I say it is 3 significant figures. After 35.6, what should be the next number? It should be 35.7. The next number should be 35.8, and so it goes like that. Before 35.6, what was the number? It should be 35.5. And there should be 35.7. 0.4, and so it goes like that. So the lower bound of 35, remember this is the number in question, 35.6. The lower bound of that number, as in the least number that can round to 35.6, will be the number that lies in between the two of them. And that number, to get that number, we add 35.5 to 35.6, then divide by 2. So lower bound, let me call it LB, will be 35.5 plus 35.6 divided by 2. Let's use calculator. 35.5 plus 35.6 divided by 2. That is 35.55. So the lower bound of this number is 35.55. The upper bound will be the number that lie between 35.6 and 35.7. How do we get that number? We take the average of 35.6 and 35.7. So upper bound, let me call it UB, will be 35.6 plus 35.7 and divided by 2. Let's do that. 35.6 plus 35.7 divided by 2 is 35.65. 35.65. So this is the lower bound and this is the upper bound. And if you are to represent this with inequality, let the number itself be x. So we write that as 35.55 is less than or equal to x, and x is less than 35.65. What this means is this number can round up to exactly 35.6, whereas these cannot round up to, or round to 35.6, because this is, if we round this up, it's going to give us 36. Okay, that is why we have less than here, but here we have less than or equal to. So take note of that. That is our for example number 1. Let's move on to example number 2. Example number 2 says, in each of the following number is given correct, supposed to be correct, not correct. Correct to the nearest whole number. Correct to the nearest whole number. Give the upper and lower bound of each number. Using x as the number, express the range in which the number lies as an inequality. Okay, so I'm going to use a number line as usual to determine the upper and the lower bound. So for the first one, I have 89 there. So if I have my number line like this is my 89 to the nearest whole number. That is the degree of accuracy. So we're working with whole number here. The next number to 89 should be 90. The next number should be 91. Before 90, we have, before 89 rather, we have 88. And before 88, there should be 87. So the number in question is 89. The lower bound of 89 is the number between 88 and 89. So here, while the upper bound is here, the number between 89 and 90. So UP, lower bound, upper bound. Okay? So the lower bound, LB, will be 88 plus 89 divided by 2, which will be 88 plus 89 divided by 2 is 88.5. 88.5. And then the upper bound, 89 plus 90 divided by 2, upper bound, and we call it UB, is 89 plus 90 divided by 2, which is 89.5. That is how to get the lower and the upper bound of that number. Then the B part of the question says, using x as the number, express the range in which the number lies as an inequality. So the lower bound is 88.5. So 88.5 is less than or equal to s, while s is less than 89.5. This is the range using inequality. That is that for question I. I wrote A instead of I. Now let's do question II here. I will have 245. Remember the accuracy here is whole number. So the nearest whole number. So the number S is 245. 245. The next whole number to 245 is 246. The next whole number to 246 is 247, and so on and so forth. The number before 245 is 244. The number before 244 is 243. So the lower bound of this number, 245, is the number between 244 and 245 itself. So lower bound is right here. Let's call it LB. LB will be, that will be 244.5. 44.5. That is this plus this divided by this, divide by 2 rather. If you are very good in calibration, you know that between 244 and 245 is 244.5. That is half of it. Why the upper bound is here, UB, the number between 245 and 246 is 245.5. That is 245 and a half. That's another way to put it. So upper bound UB is 245.5. Now using inequality to represent the range, that will be 244.5 is less than or equal to S, and S is less than 245.5. That is that for question number I. So question number I. Let's create some space to get. Okay, for the last one then, we have 756. 756 is I. Again, if you represent that on a number line, 756, remember the accuracy here is whole number. Say to the, each of the number is given correct to the nearest whole number. So correct to the nearest whole number, meaning there was a value before it was rounded to the nearest whole number. So what is that value? That is what they're asking us. That is the meaning of upper and lower bound. So 756, the next whole number to it is 757. And before 756, we have 755. So the lower bound will be number between this 755 and 756. Let's call it LB. The upper bound is the number between 756 and 757. Let's call it UB. And here, that will be 755.5. So the lower bound, if you are not sure, you can add this to this, then divide by 2. It will be 755.5, while the upper bound is 756.5. Using inequality to represent that, our 755.5 is less than or equal to x, as the number is x now, while s is 750 is less than 756.5. Okay, that brings us to the end of example number 2. Let's move on to example number 3. Example number 3 says each of the following numbers is given correct to one decimal place. Give the upper and lower bound of each number Using S as the number, express the range in which the number lies as an inequality. So for the first one, I have 3.8. I represent that on the number line, 3.8 to 1 decimal place. So the next number to it will be 3.9. The next number before that is 3.7. In between this 3.7 and 3.8 lies the lower bound. And in between 3.8 and 3.9 lies the upper bound. Now, if you are not very sure, add this number to this number, divide by 2. That will give you the lower bound. The upper bound, you add this to this, divide by 2. That will give you the upper bound. So in this case, I am used to calibration. I know that between 3.7 and 3.8, there is 3.75 there. So lower bound is 3.75. Now in between 3.8 and 3.9, there is 3.85. So that gives me my upper bound. Again, if you are not sure, add this number to this number, divide by 2. So my upper bound is 3.85. Now if I use X again to represent the number, then, okay, that is what they even say we should do. Representing that in inequality as 3.75 is less than or equal to S, and S is less than 3.85. That is up for question I. And let's do question II here. For II, we have 13.7, 13.7. Since we are working to the nearest bit, or to 1 decimal place rather, the next number to that will be 13.8. Then before 13.7, there should be 13.6. So the lower bound is a number that lies between 13.6 and 13.7. This is the lower bound there. The upper bound is the number that lies between 13.7 and 13.8. I call it UB, upper bound. Let me create some space on the board. Okay, so to get the lower bound, if you are not sure, add 13.6 to 13.7, divide by 2. That will give you the number there. So LB is 13.665. That is the number there, the lower bound. The upper bound UB is 13.75. That is the number right there, 13.75. Using inequality, 13.65 is less than or equal to S, and S is less than 13.75. That is that. Then the last one is 1.0, not the last one, second to the last. 1.0. 1.0. Remember, we are working to 1 decimal place. The next number to 1.0 is 1.1. That is what you need to take note of. Some students here will write 2 instead of 1.1 because the degree of accuracy is to 1 decimal place. To 1.2, and before 1.0, we had 0.9, and then 0.8, and so it goes like that. Now, this is our number X. In between 0.9 and 1.0 is the lower bound. Then in between 1.0 and 1.1 is the upper bound. How do we get the lower bound? 0.9 plus 1.0 divided by 2 will give us the lower bound. So in this case, it is 0.95. Whereas the upper bound UB, 1.0 plus 1.1 divided by 2 will give us 1.05. That is the upper bound. Let me confirm that with a calculator. 1 plus 1.1. Then divided by 2. Yeah, 1.05. So using inequality, 0.95 is less than or equal to S, and S is less than 1.05. That is the upper and the lower bound of that number. Then lastly, 0.6, 0.6. 0.6, the next number, remember we are working to one decimal place. The next digit to this is 0.7, before it is 0.5. So in between this is the lower bound, and then in between this and this is the upper bound. So let the number itself be x. To get the lower bound, we add this to this and divide by 2. So in between 0.5 and 0.6 is 0.55. If you are not sure, add this number to this, divide it by 2. So lower bound is 0.55, while upper bound is 0.65. Using inequality, that means 0.55 is less than or equal to S, and S is less than 0.65. That is that for question number 3. Let's move on to question number 4. And it says the population of a town Y is giving us 280,000 people, rounded to the nearest 1,000. Find the upper and lower bounds of Y and state the error in the interval. Okay. Again, I'm going to represent this on the number line. This is my number line. The population is 280,000 to the nearest 1,000. After 280,000, the next number should be 290,000. Since it's to the nearest 1,000. The next one before that is 270,000. So in between this is the upper bound and this is the lower bound. The lower bound, we add this to this and divide by 2. 270 plus 280 divided by 2 is 275,000. 275,000. Then the upper bound, 280 plus 290 divided by 2, 285,000. Then using Y, according to the question, 275,000 is less than or equal to Y, and Y is less than 285,000.